Otherwise, why don't you give number 1 a try? Great, but please do focus on this. Let's make sure. Let's try to make as sure as we can that your steps are perfect. My steps are perfect. We all agree. We're all good with number 1 before we move on too far. Okay, so with number 1, listen please. Number 1's in slope-intercept form, right? Wrong. It's not in slope-intercept form, is it? It's actually in something we call standard form, which we've chosen not to use. So we need to convert this over to slope-intercept form. So Victoria, if I was going to convert over to slope-intercept form, what might be a good first step? You don't know? Joe? Listen carefully to Joe.
Subtract the 5x.
Why? Like, what's the point of that? Like, why would I subtract the 5x?
Because you're trying to isolate the y.
Did you hear that? That's what we're trying to do. We're trying to isolate the y. Subtracting the 5x over is a good move if that's the goal. So negative 2y is greater than negative 4 minus 5x. Aiden, what do you think for a next step? Once I got to this point, what would you do?
I would divide by negative 2.
I agree. I think that's a good move. Did you, when you did that, did you pick up on the little trick that we got to deal with when you divide everything through by a negative?
Don't we flip the sign?
The inequality, right?
Mm-hmm.
Yeah, the inequality does need to flip around. So it would be now y is less than instead of greater than?
Yes.
Yeah, perfect. Okay, so then on the right side, negative 4 divided by negative 2 is actually positive 2. And then negative 5 over negative 2 is really plus. And so is that in slope-intercept form now?
Yes.
It more or less is. I mean, yeah, you could rewrite it to be y is less than 5 halves x plus 2, but it really is in slope-intercept form at this point. So let me just pause for a second here. You guys have any questions about how to go from this to that? Any of those steps seem unclear at all? You guys supplied them. I thought they were great steps. Any questions at all? Okay, so I want to ask you the same question I asked you last time. In order to graph a line, what are the 2 things that you have to have? A point that's on the line and the slope. That's right. So point that's on the line and a slope. Coy, what's the slope of this line?
5 over 2.
I agree. It is. That's not a very good 5. 5 over 2. Colton, what is the point on the, that's on this line? 0, 2 is correct. It's the y-intercept. That's why it's 0, 2. Well said. Okay, you guys are putting this together pretty well. Last question here before we get this on the graph. When I do graph it, do I graph the slope before the point, or do I graph the point before the slope? Always the point first. Good. So 0, 2 is right about here. And then I'm going to count my slope off. My slope is up 5. So up 1, 2, 3, 4, 5, right 2, and that puts my point right about there. I could also reverse this if I wanted to. I could go down 5, left 2. Put me in the same pattern. Okay, so then I'm going to connect all those points with what hopefully will be a lovely line. Oh boy. We're going to call that fairly lovely right there. All of your lines should have arrows on the end. I got to decide now, is this line going to be a dotted line or a solid line?
Dotted.
Why would it be dotted? It's not the or equal to. Yep, it's just less than. So I'm going to go through and make that dotted. There we go. And then the last thing I got to decide is, where do I shade? Am I going to shade down and right or up and left? And we could call this region A. We could call this region B. How do we decide? Is it region A or is it region B?
0, 0.
Test out 0, 0. You think it's B. Okay, well, let's find out. So if I test out 0, 0, I think this will tell us all we need to know. So testing out 0, 0, I'll just test it out in the original. That would be 5 times 0 minus 2 times 0 is greater than negative 4. Well, 5 times 0 and 2 times 0 are both 0, and 0 minus 0 is 0. So 0 is greater than negative 4. Is that true or is that false?
It is true.
It's totally true, isn't it? Yep, absolutely true. That means the region that contains 0, 0 is my answer region, and that would be which one?
B.
B. You were right when you said B earlier. So there's my answer region. So when I shade that, can anybody explain to me like what that means when I shade? What does it mean, Josh?
Means that like any answer in that area or on is a possible answer to the equation.
You said any answer in,
Or any coordinate.
any coordinates in there, but you said or on. What do you mean by or on?
Did I say or on?
I thought so.
I don't think. I did, but-
Let me ask you this.
Oh, well.
I think you said it very well. He said any of the coordinates in that shaded region will do what?
Solve the.
Or make it true.
It'll make it true. Yep, it'll make the original inequality true. Let me ask you this.
I'm bad with words.
No, I think you're pretty good with words, really. You just had a little hard time spitting out at the end, but I thought you were doing really good up to that point. What do you guys think would happen if I plugged in any of the points that are actually right on the line? Do you think plugging in points that are on the line would prove a truth or a false?
False.
Why a false?
Because it's not or equal to.
Yeah, and the line is dotted, right? Well said. Now, if the line was solid, then it would prove to be true. But it's only going to be just the red shaded region, like you pointed out. Okay, so everybody that I talked to, I think, was either there or in a good progress towards getting there. Do you have any questions? Doing pretty well. Okay, well then let's, if you haven't already, move on to number 2 and see how this goes for this one. Yeah, because there's an or equal to. You're right. Okay, so far so good. The last thing I got to consider is the shading. And that line right there has created 2 regions. One of them over here on the left, this one over here on the right. And I need to figure out which region it is. How have we been deciding which region to shade?
Plugging in and stuff.
Plug what in?
0, 0.
0, 0, because the line doesn't go through 0, 0. Those numbers specifically would be good. So I'm going to test out 0, 0. And what is the only input in my inequality?
Just replacing the
X.
Yeah, the only input is x. So that's the only thing I can really do here. So I'd say 0 is less than or equal to negative 1. And we just decided if that's true or false. So is 0 really less than or equal to negative 1?
No, it's false.
That is totally false. Therefore, I tested out region B, essentially. And region B didn't work out. So it had better be region A. So I will shade over there. And any number that I test out from that region should create truth in my inequality. So solid line, shading on the left this time. Any questions? So I think we have a concept quiz on this next week sometime. I'm hoping right now you're feeling like you're rounding into shape, that this is making sense. We good? All right. If you haven't tried number 3 yet, please try number 3. Ready to go. For the little saying in regard to like snowboarding and skiing, that if you approach the slope like what you're about to see, you would ask yourself, why would I ski that? Because if you just have a y with no x's, horizontal, right? So horizontal line at 2 would look, I'm going to go with a straight line. How about this? That's better. So there's my y equals 2. Put arrows on the end. Is this going to be one of those dotted lines, or is this still solid like before?
Dotted.
Why is it dotted?
It doesn't have or equal to.
Yeah, the or equal to is not there, so we have some little gaps here, dotted line, something like this. Now, hey, listen up, please. What I've basically done, by graphing that line, I've created 2 regions of my graph. One region is up here. I'm going to call it region A, and the other region is region B. Region B includes the x-axis and all the y values up to like 1, almost up to 2. Region A is all the y values above 2, right? So what I want to do, basically I'm either going to shade here or I'm going to shade here. It's got to be one of those two. There is no in between, right? So the way that I decide which one I'm going to shade is I'm going to test something out. And we test 0, 0 out a lot because 0 is typically a nice convenient number. The truth is we could test out anything we want. So let's change it up just to be different. Why don't we test out this point right here? Let's test out 4, 5. So this won't be that bad at all. We could test out 0, 0 if we wanted, but here we go. If I test out 4, 5, look back at my inequality. What is the only input in that inequality?
Y.
A y. And so my test value's y value is 5, right? My test value is 4, 5. This is x, this is y. And so I'm going to test out 4, 5. The only place I can put anything is for the y, and y is 5 for my test value. So I would write 5 is greater than 2. So is 5 really greater than 2? Yep. So that is totally true. That means that the region containing my test value is the region that contains all my solutions. So I would shade up here. You didn't have to test 5, 4. You could have let's test 0, 0 like we've typically been doing. So if I test out 0, 0, well, again, the only input is for y, and for my test value, which, and of course, my test value is right here at the origin. My y value is 0. So what I would do there is I would say 0 goes in for y is greater than 2, and then I would consider the truth or falseness of that. Is 0 really greater than 2?
No.
That's false. So what that means is, like when I tested out 0, 0, I was really testing region B, and that proved to be false. Therefore, my answer region is not B. It's got to be the other one. In this case, it's A. Does that make sense?
Yeah.
So you could test out 50,000 other points if you want. You'd either get a true or a false, and you'd act accordingly. Is that good?
Yeah.
Sweet. Okay, you bet. Other questions, concerns? Fantastic. Let's wrap this up with number 4, which is right here. We're going to graph this, right? We're kind of come full circle here. Jaden, see right here? Is this in slope-intercept form?
No,
Why not? I really want it to be.
because like you haven't put it.
I got you.
You're right. It's not in slope-intercept form. Hold on. You want to keep thinking, Jaden? Okay. Noah, what would you say to that?
Well, I'd say it's not just slope-intercept form because slope is y equals mx plus b.
And what's the key feature of that?
The y is by itself.
Right? The y obviously right now is not
Yes.
by itself. So if you could get it there, that makes sense, Jaden?
Yeah.
The y is not by itself. Needs to be. Okay. So then, Ava, what would be your first step to get that?
I would subtract 2x on both
Oh,
sides.
excuse me.
Bless you.
What is it, 2?
Okay, so take a look at that first step. Ava has suggested a very good first step. I hope that's what you would do. So what results from that is -3. Y is less than -18 minus 2x. So from there, we still don't have the y all by itself. Chase, what would you do?
Divide by 3.
No,
Negative.
-3. So I am going to write it out like this. I think your suggestion is a very good one. So I'm going to divide all 3 of the terms on both sides by -3. So y, what should be the very next symbol that I write? Irene?
Well, you flip the symbol.
Yes. So now it's greater than. Remember, whenever you divide everything through by a negative, or for that matter, multiply everything through by a negative, the inequality gets to do a little switcheroo, flips around. Okay, -18 divided by -3 is positive 6, and -2 divided by -3 is positive 2/3, so 2/3 x. Believe it or not, one of the most common mistakes people make is they forget to write the x. Once they get there to slope-intercept form, make sure that that is there. I've already fielded plenty of questions on WebAssign where it's like, I know I got this right. I know I got this right. And I'm like, where's your x? And they're like, oh, let me put that x in there, and hey, green check. It happens, right? So Don't stress. Just look at it and realize that's what you got to do. So from this, we can figure a couple of other things out. Nick, we should be able to figure out our slope and our y-intercept from this. So what is our slope?
Our slope is
2/3. That's right. Our rise is 2. Our run is 3. And the point, of course, is the y-intercept because this is slope-intercept form. So Josh, if we're going to find this point here, what would it be?
This point.
The point that's on the line.
The point that's on the line would be 6. No. Oh, wait. We're going from. No second.
Okay.
To be quite frank, I wasn't really paying attention.
Well, let's repay attention. I appreciate your frankness, Josh. But you missed it on a technicality. You didn't miss it because you don't know what you're doing. You missed it on technicality. 0.6. There we go. 0.6. So point is always x comma y. It's never just a singular number. Okay, so I'm going to graph that point first. Hope you guys have the point right there, 0.6. Slope is 2/3. So I'm going to go up to right 3. Up to right 3. There's a point right there. Up to right 3. Another point right there. So on and so forth. There we go. Look at this beautiful line. That's good enough. There we go. Arrows on the end. Now let's make our decisions on the other stuff. Should this line, Faith, be dotted or solid?
It should be dotted.
Okay. Can anybody explain why this needs to be a dotted line? Faith said dotted. Why is it? Why would it be?
Because what's it called,
Inequality.
the inequality is not or equal to, so
Yep.
the lines show that it cannot equal the line.
That's right. It's not part of the solutions. Agreed. Okay, so we got a dotted line. Now we got to decide where we're going to shade. What did you guys test 0, 0? That makes sense. Okay, so let's test that out. So I test 0, 0. I've got inputs for both x and y here, so it's going to be 2 times 0 minus 3 times 0 is less than negative 18. We end up with 0 is less than negative 18. So is that true? Is 0 smaller than negative 18?
Yes.
I say no, actually. Isn't
Oh, wait,
negative
sorry,
18? If
sorry,
it was
I
positive
thinking
18.
Yeah.
Yep. Okay, so that means that 0, 0, which is right here, is not part of my answer set. And so I need to shade over here to show all my answers. Okay, so like we always do, please take a look at what I have, look at what you have. Let's compare and make sure that we are in agreement. Or if we're not in agreement, let's talk. Let's decide what happened, what we could do to do better. I'm seeing a lot of good answers here. Question, yes?
For the second have it on this actual graphic,
Uh-huh.
I want us to show the point we tested.
Oh, you mean like
mentally.
this right here? Or sorry, this over here?
Yeah.
So I think a couple different perspectives on that. I totally get it, especially if you can test 0, 0. It's not that hard to test. You have plenty of time. You have plenty more time. You don't need to be done right now. Are you sure? You can be done if you want, but I'm just saying don't feel rushed.
Okay.
Don't feel rushed at all. Take your time, check it up if you want. So I totally get it. You can plug in 0, 0. You probably could do that in your head. Totally fine with that. But do consider this from the perspective of me trying to understand, like with those concept quizzes, my goal is to ask this question: how much does Noelle really know about this? Right? And if you show those steps, and maybe you do make some little crazy, silly error, I can look at it and be like, oh man, she absolutely knows what she's doing. She just did a silly, silly thing here, and that's going to like shade the way that I think about your skills. Versus there's nothing there, and she shaded the wrong side. I kind of have no idea what went right or wrong. So showing your work is always better, right?
Yeah.
Just because you're trying to communicate, and it helps me understand. Because, I mean, isn't it nice when a teacher is like, think about it like this. Like when you miss something, say on a science test or a math test or an English test, and you try to, you know you missed it, but you're trying to help your teacher understand like why you did what you did. Isn't it nice when your teacher is like, oh, I totally get it.
Yeah.
I understand why you did what you did. I mean, it was wrong and everything, but I totally get it. That's awesome, right? Thank you, Jasmine. But it's really hard to come to that conclusion when you look at the work and you're just like, I have no idea what she did because there's nothing there to really look at. So just consider, because I genuinely want to understand why you got it right or why you got it wrong or whatever. So you guys look pretty good. Solid? Yes? Good? Okay, cool. Grab something that you can be doing homework with or something productive in the math realm. And I'll be around to help if you need it.